Hello, my dear students. So, in this lecture series, I am going to solve you some of the numerical regarding the JEE Advanced. So, today's numerical is basically to calculate the value of M1. So, there is a pulley block system where there are two masses are suspended. So, this mass is M1. So, this is M1 and there is another mass M is connected with the spring. So, you are asked to calculate the minimum value of M1 required to lift the mass M. So this is the system where you put the value of M1. So what is the minimum value of M1 that is required to lift the mass from the ground? Initially the mass is resting on the ground and we say that initially there is no extension inside the spring. So when I put the mass, so M1 mass is there. Let us say the mass is being dropped by distance of x naught. Okay. Now because of that, now the spring will be extended by x naught. So what you can write for the mass M1 and K as a system. So drop in potential energy is equals to the gain in potential energy for the spring. Gain in potential energy for spring. Why? Because initially the M1 mass is suspended. If I drop the mass by x naught distance, if the mass is pulled down by x naught distance, then what happens? There is a drop in potential energy. So now what is that drop in potential energy? That is equals to mg into x naught. Now this number is basically used to increase the kinetic energy, increase the potential energy of the spring. Why? Because now the spring has been stretched by another x naught distance. So for that reason, the spring has stored some kind of spring potential energy. That is equals to half k into x naught square. Okay, so this is m1. So m1g times x naught should be equals to half k into x naught square. So from that, what we got, that kx naught number, that is the spring force. That is nothing but the spring force. That should be equals to 2 times of m1g. Okay, so this is the spring force acting, and that spring force is able to lift the mass m. So for the mass m which is resting on the floor, so above that the force is k times x naught, that is the spring force. Okay, and there is a normal reaction acting upward and the mg is acting downward. So in order to lift the load from the ground itself, the condition is that n number should be equals to 0. Okay, so normal reaction should be equal to 0. Now what is that n number? So n can be written as equals to mg minus kx naught number, and that is equals to 0 in order to lift the mass. Okay, so that means what we got, that condition to lift the mass is that mg must be equals to kx naught. So what we write, mg must be equals to kx naught. Now initially you got the kx naught number equals to 2 times of m1g. That is equal to 2 times of m1g. Okay, so from that what you can conclude that m1 number, so minimum value of m1 is equals to m by 2. Okay, so if I put a mass of m1 by 2 over here or m by 2 over there, then we can lift the mass m. Okay, so in order to lift the mass m, let us say the mass of m is 20 kg. So that means in order to lift the mass of 20 kg, you have to put a mass of 10 kg over here. So that can be used to lift the mass. Okay, so that is the answer. Thanks for watching my video. If you like, please subscribe my channel. Okay, bye then.